Benzylic, allylic, vinylic, and arylic halides in nucleophilic substitution reactions. Here are the structures of benzylic, allylic, vinylic, and arylic halides.
Do benzylic and allylic halides undergo SN2 reactions? The answer is yes. Just as we have seen in the case of alkyl halides, primary and secondary alkyl halides would undergo SN2 reactions. In the same way, the benzylic and allylic halides will also undergo SN2 reactions, provided they are not tertiary halides. This is a primary benzylic halide. And this is a primary allylic halide. Okay, remember, for it to be an allylic halide, you need to have an halogen attached to an sp3 carbon, which is attached to the vinyl group, right? Okay, so when it is reacted with nucleophiles, the same thing as what had happened in the case of alkyl halide, primary or secondary alkyl halide would happen here. So which in this case, the OCH3 minus, which is your nucleophile, will come and approach the carbon in the side that's opposite to that of the leaving group, and the leaving group leaves and it leads to the formation of the product, which is benzyl methyl ether here. And in the same way, let's choose another nucleophile here. Let's say that we have OH minus here. Again, this is going to go attack the electron deficient carbon and thrust the leaving group out, leading to the formation of an alcohol, an unsaturated alcohol. Let's also understand the differences between benzyl group and a phenyl group. In a benzyl group, you need to have this methylene group that is directly attached to the benzene molecule. So this is your benzene molecule. And when you have an halogen that's present here, then it's going to be called as benzylic halide, right? But for the phenyl halide, you need to have the halogen directly on the benzene ring. Okay, so this is an example for a phenyl halide when you have an halogen there. The name for this one is going to be called as benzyl bromide. Whereas the name for this, when you have a bromine right here, it's called as bromobenzene. Okay, so these are two different molecules.
Let us go on to this molecule right here. We can see that this is definitely not a benzylic halide because the bromine is not connected to a benzylic carbon. So this carbon right here is the benzylic carbon. Only if the bromine is attached to this carbon, you will be able to call this as benzylic halide. This molecule can be considered to be a substituted ethane molecule, where you can see that this is your ethane part.
On ethane is present a bromine and as well as a phenyl group. Now what positions are they present? Obviously this carbon right here is going to be 1 and this is 2, following the alphabetical order. So it should be 1 bromo, 2 phenyl, ethane. That would be the name for this. Now we are very clear on the differences between what is a benzyl group and a phenyl group. Now, can benzylic and halidic halides undergo SN1 reactions? The answer is again yes. Now, why? Because they are able to form carbocation. When it comes to SN1 reaction, you're talking in terms of carbocation, whether they are able to form a stable carbocation. Yes, they are definitely able to form a stable carbocation, right? So once after the Cl minus leaves in an SN1 reaction, it's going to lead to the formation of carbocation. Let's draw the structure for the carbocation. And once that carbocation is formed, you can see that it is resonance stabilized. These electrons can come in here through delocalization, and this positive charge will be distributed through the entire molecule, right? Leading to different resonance contributors. And then it can react with the nucleophile. The CH3OH can go and attack in the top portion or in the bottom portion, leading to the formation of the product. Right? There will not be any stereoisomers for this product because this carbon has 2 hydrogens on it, which is exactly the same group, right? So the product here would be this. And in the same way, when you have an allyl bromide, it can also undergo SN1 reaction, which case again the Br minus is going to leave. Once it leaves, it's going to form the carbocation, the allylic carbocation, the allylic carbocation will be resonance stabilized. And here is the other resonance contributor for allylic carbocation. Right? And in the next step, the nucleophile can go and attack this carbocation, forming the product. Here in this case, these two resonance contributors are mirror images, so it's going to lead to only one product. In some cases where it doesn't give you exactly the same resonance contributor, it can lead to more than one product. So here is the situation. So in this case, if once the Br minus is going to leave, it forms the carbocation. The carbocation will undergo delocalization to form another carbocation. So here in this case, this is a primary carbocation that's formed, but here it is a secondary carbocation that's formed. Now, the nucleophile can go and attack each one of these carbocations to give our product. And in the final step, deprotonation occurs, thereby leading to the formation of the alcohols. Products that are obtained here are different. Now the next one is, do vinylic and arylic halides undergo SN2 reaction? The answer is no. Vinylic and arylic halides do not undergo SN2 reaction. The main reason here is the electron repulsion. Now what is happening in an SN2 reaction? In order for SN2 reaction to happen, you need to have a nucleophile, and this nucleophile need to go and find the carbon where the halogen is attached. Right? So it needs to go and attack in the site that's opposite to that of the leaving group, and the leaving group needs to leave, right? As this nucleophile approaches this carbon, remember there is a double bond on this carbon. So which means the double bond is going to exist as lobes of electrons, one above the plane and the other one below the plane. But this nucleophile will be repelled by these pi electrons, right? So the pi electrons are, obviously there is a negative charge on the electrons, right? And the nucleophile also has got negative charge, and therefore they will be repelled, and because of which they are not going to undergo SN2 reaction. And here again, it's exactly for the same reason. As the nucleophile comes and attacks this carbon, it will be repelled by the pi electron cloud, right? And therefore, the aryl halides do not undergo SN2 reaction. So both vinyl and as well as aryls, they do not undergo SN2 reaction. Now, do they undergo SN1 reaction? The answer is again no. Now let's see why they don't undergo SN1 reactions. What is the first step in the SN1 reaction? It needs to form the carbocation, right? So the first step here is the Cl minus needs to leave, and once it leaves, it needs to form the carbocation. Now, what kind of carbocation is this one? This is a vinyl carbocation. The vinyl carbocations are very, very unstable, right? And similarly, if you take a look into the aryl halides, as soon as this Br tries to leave, it needs to form the carbocation, right? The aryl carbocation. The aryl carbocations are again unstable. Because both of these are unstable, it's not going to lead to the formation of the product. On the whole, the vinyl and aryl halides, they do not undergo SN1 reaction because they are not able to form carbocations, and they do not undergo SN2 reaction because of electron repulsion from the pi electron cloud.